Good morning, my dear friends. I am Dr. K.V. Balasubramanian. This is my YouTube channel, Balavin Kural. As I have already told you all that I am planning to release a series of videos in connection with the Azadi Ka Amrit Mahotsav from 26th January to 15th August 2022. About 60 videos are planned 3 times in a week. And the topic of the series is growth and development of India Meteorological Department. We are actually in seen 3 videos on weather radar. So first video, I have explained what is the science of radar. Second video, how the radars came into India Meteorological Department from 1954 to 1972. Then I have, while talking about the growth in 80s and 90s, I have narrated some incidents that has happened in the S-band radar stations at Karaikal. S-band radar station at Karaikal. So today we have to see what is the further growth from 90s to the first half of 2000s. So as a recap, I want to repeat some things here. The Meteorological Department had 2 types of radars, X-band radars and S-band radars. Immediately after the Indian independence, India Meteorological Department was placed under the Ministry of Civil Aviation, considering the very important part that IMD is having with regard to aviation services. So the idea, priority was given to install X-band radars in all airports, at least in important airports. In that way, X-band radars were introduced. Initially, the power of radio waves generated by the radars were weak. So they were replaced with high power X-band radars. Then in 1970s, first S-band radar was installed. It was shifted to Dolphin's Nose at Visakhapatnam. The second S-band radar was installed at Madras, Mitsubishi RC32E radar. Then Kolkata, Paradeep, Visakhapatnam, Masulipatnam, Chennai, Karaikal in the east coast, Kochi, Goa, Bombay, Bhuj in the west coast. S-band radars were sorry. Why we need S-band radars? That is because these X-band radars have a effective range of 200 kilometers, and S-band radars have an effective range of 400 kilometers. Though it can look up to 500 kilometers, the effective range is 400 kilometers. When a cyclone is within the radar range, the radio waves that are generated from the S-band radar should go and penetrate the strongest clouds associated with the wall cloud region of a cyclone. So it should see this end as well as that end of the circle or ellipse of the wall cloud region. So the wave should be of that much strong. So for that, S-band radars were introduced. But these radars were not just finding the position, movement alone. Means there were two modes: plan position indicator mode and range height indicator mode in the display of the radar. So plan position indicator mode will give you the position. Range height indicator mode will give you the height of the clouds. That's all. These two things were only basically available products, but many things were tried with the cyclone detection. The radar meteorologist, with all the research work that were going on in the foreign countries, same thing was repeated here for the Indian conditions, and found out how to determine the maximum wind speed associated with the cyclone by finding out the maximum reflectivity. So for this, research was going on. Our one of the great radar meteorologists in IMD, Sri S. Raghavan, he is no more now, 1 year over after his death. So he has done very good work in this connection. And also, they were trying to estimate the rainfall from the clouds of the radar. So in those days, it is very difficult to operate the radar continuously for 24 hours. So only during a cyclonic storm time, we can take hourly observation. That is also discrete. There is no continuous. Okay. So with whatever observations available, they tried to correlate the rainfall happen. So this rainfall happen can be compared from the rain gauge stations located within 200 kilometers from radar. Not all the 400 kilometers, it will not be able. We will not be able to compare. So this is the effective range. That is because of the curvature of the earth, the radio waves will be scanning 2 kilometers above or 4 kilometers above, 6 kilometers above as it goes away from the radar center. So due to this problem, and the radar is blind to see 20 kilometers around it. That is also there. So this 20 kilometers to 200 kilometers, if we have a network of rain gauge stations, those information can be collected and compared with the radar information. This radar reflectivity is related to the rainfall by a formula given by two scientists, Marshall Palmer, rainfall equation. In the two constants were there. These two constants have to be determined for Indian conditions for different seasons, because it basically depends upon the drop of the precipitation that is happening. If it is drizzle, it's slightly different constant. If it is rain, slightly different constant. Shower, different constant. So like that. So for various seasons, 2 or 3 years, we have to do some research, find out what exactly the empirical values of these two constants can be kept. So using this, at the time some computers were coming, very old, this one, computers. It is not like what we have now. So they tried to use that also, calculating machines, mechanical calculating machines, calculators, so many things they tried and found out some method to determine the rainfall from the radar echoes. So this has several preconditions. Number one, the radar has to work 24 hours because rainfall is measured from 8:30 in the morning to next day morning 8:30. So during that period, continuously radar has to work. So here continuously it is not possible. Every 1 hour the radar has to work. Then we should have rain gauges which should report uh, uh, this one rainfall. Rainfall amount, and also should have a self-recording rain gauge which will record 24 hours rain gauge. So if these two conditions are there, then this research can be done, and the relationship of Marshall-Palmer relationship, the two constants associated with that equation can be determined. This work was also done with the RC-32E Mitsubishi radar, which was installed in 1972. Again, Mr. Raghavan, late Mr. Raghavan has took pioneering effort in this line. But as the electronics improved, as computing technology improved, these things were simplified and put together in a radar system. That is what Doppler weather radar. So to operate a Doppler weather radar, there are some prerequisites are there. What are they? How a Doppler radar works? We will see in the next video. Thank you.